Start our next section, 6.3, Part C. 6.3, Part C, the third example of the lesson. We assume a population of 2, 3, and 10. Assume the samples of size n equals 2 are randomly selected with replacement from the population. Below are the 9 different samples. So what it's saying, it is definitely independent because you can get the same item out twice. So then we're going to notice that they gave us the 9 different samples, and we understand them now because we've done a couple. The 2, 2, the 2, 3, the 2, 10, the 3, 2, the 3, 3, the 3, 10, the 10, 2, the 10, 3, the 10, 10. Okay, now it wants the value of the population standard, and we're going to use our TI-84 calculator. And you can always pause the video and make notes about how to do it. I'll talk through it so we do not lose time. So here we go. I'm going to go to the Stat, Edit, and you can see I entered on line 1, 2, 3, and 10. So I have all of them there. I want to give the calculator a command to give me the standard deviation. So I'm going to go Stat, arrow over to Calc, and choose number 1, the 1 variable stat. And because it's population, we want the standard deviation of x, which is 3 56/100ths. So now we have that done. We're going to now find the standard deviation of each of them. We know that the standard deviation and actually for this one it's samples, so I better write it as S equals the square root of S squared, the variance. And we know that this is n minus 1, so we only have 2 items, so we're going to just enter what we need. So let's do first for standard deviation, and we need variance to subtract from every single element that we add, square, and add up. So here we go. We got to do the mean, and the mean is 2 plus 2 divided by 2 elements, which is 2. And now we have the 2 plus the 3 divided by 2, 5 halves, 2 1/2. Now the 2 plus the 10 is, the 2 plus the 10 is 12, divided by 2 is 6. The 3 and 2 is the same, so this is a 2 1/2. The 3 and 3, well, the average is 3. The 3 and 10 is 13 halves, 6 1/2. The 10 and 2 is like the 2 and 10. We're going to get a 6. The 3 and 10 we just did, got a 6 1/2. And this one is 10. So we can see that our means are there. Now we're going to do the standard deviation. And I'm not going to do by divided by 1. So we're going to do our 2 minus 2 squared plus a 2 minus 2 squared, and that is 0. On this one, I'm going to have the 2 minus the 2 1/2 squared plus 3 minus the 2 1/2 squared. So we're going to do our calculator for that guy. And I'm going to do second square root, open parenthesis, 2 minus the 2.5, close parenthesis squared, plus open parenthesis the 3 minus the 2 1/2, close parenthesis squared. Making sure I didn't forget a square, and I get 707. All right, now I have this guy, which I'm going to do the square root of 2 minus 6 squared plus 10 minus 6 squared. Okay, and it's all over 1. So let's do it on our calculator. Second square root, open parenthesis, 2 minus 6, close parenthesis, squared, plus, open parenthesis, 10 minus 6, close parenthesis, squared. And I get 5 66/100. All right. So these two are the same. So from the ordered pairs, so this is 707. The 3 is the same number, so that's a 0. There is no variance there. Now this one is a 3 and 10, and I don't have a 3 and 10. And this is the first 6.5. Okay, here we go. So I'm going to have 3 minus 6.5 squared plus 10 minus 6.5 squared. And we're going to get some kind of value there. Of course, I'm going to use my calculator. Second square root, open parenthesis, 3 minus the 6.5, close parenthesis, squared, plus open parenthesis, 10 minus the 6.5, close parenthesis, squared. I got to make sure I got my decimals in there, and I'm good. There it is. So on this one, I have 4.95. Okay, I have a 6 here, which is a 10 and a 2. So that is a 5 and 66/100. A 6.5, which is a 10 and the 3, which I did up here, right here. So all the same. So it is a 4 and 95/100. And then the 10 is 0. All right. So what are my values? 0, 707. Oops, I have a 566. Sorry about that. 5. No, I was right. That was a decimal. 707, 495, and 566. Okay, on the zeros, I have 1, 2, 3. On the 707s, I have 2. On the 495s, I have 2 and 2. And I have 9 elements. All right. So I'm good there. Now we're going to do the probabilities of the standard deviations. Okay, so I have 0, 0 and 707, 4 and 9, 5. I should have done 3, huh? I should have. Well, that's okay. I think we should have done 3 on that one. 9, 5. Let me look at my calculator. 9, 5. No, it's the same because it's a 0. Okay. Excuse me. I'm sorry. And a 5, 6, 6. And that's what I'm going to leave it at. Okay. So this is going to be 3 out of 9, 2 out of 9, 2 out of 9, and 2 out of 9. That gives me a 1. Now it says find the mean of the sampling. All right. Let's do that. It won't let me see. Let me get this larger. Yes, it will. Okay, the mean. So on the mean, I have, and this is the mu of x. And this is going to be 0 times 3 plus 707. Yes, 707 times the 2 plus 5, 566 times the 2. Oh, I left one out, sorry. 495 times the 2. And it's all divided by 9. And when we do the math, 707 is not as pretty as the other one we did, where it came out with nice numbers. 5.66 times 2 plus 4.95 times 2. Okay, 70725662496. Okay. And we're going to divide it by 9. Oops. Right. Do the standard deviations match? No. No, they don't. The one we got for the population was 356. And the one we have for this one, so it's a no. And we know that because of the effect of the change in samples. Right. So I'm going to stop right there, and then we'll do example 4. Thank you.